Hello and welcome to the very first lecture of this API development series with Python. In this course, we will learn everything about API development step by step without skipping any topic. Let's start this course by having a brief overview of what is an API, how do API works, and what is Web API. Let's pick up the first topic and understand what is an API. API stands for Application Programming Interface. API architecture is a client-server architecture in which the application sending request called the client and the application sending response is called as a server. In other words, API allows two different applications to talk with each other, and it also allows the user to make use of resources running on the different server. Every application that we are using in our day-to-day life are relies on the APIs as they can ship information from one technology to another. Now let's move on to the another topic and understand how does API works. API works on client-server architecture. The application sending request is called as a client and the application sending response is called as a server. Basically, there are four different ways that API can work. Those are SOAP API, RPC APIs, WebSocket APIs, and REST APIs. Let's discuss on these APIs one by one and understand how they work. SOAP APIs uses Simple Object Access Protocol. In this API, client and server exchange messages using XML. These are less flexible and was popular past days. The second is RPC API. These APIs are called Remote Procedure Calls. In this API, client completes a function or a procedure on the server and the server sends output back to the client. The third is WebSocket API. WebSocket API is one of the modern web API that uses JSON object to pass data. A WebSocket API supports two-way communication between client and server. That means the server sends callback message to connected clients, making it more efficient than REST APIs. And the last is REST API. REST stands for Representational State Transfer. REST defines a set of HTTP functions like get, put, post, delete, etc. that client can use to access server data. REST APIs are most popular and flexible these days, in which the client sends requests to the server as a data and the server uses the client input to start the internal procedure and returns the output data to the client. During this process, the server do not save client data between requests. REST APIs are also known as Web APIs as they uses the standard client-server architecture style and can be used as a URL to access the REST endpoints with the help of web browser and the web server. Web APIs or REST APIs exchange the information between web browser and the web server, which means we can type any URL in the browser to visit the REST endpoint and can get the response from the server in a plain JSON data without rendering a web page. This brings us to the end of the first lecture. In this lecture, we have discussed about the APIs, their working and their type. In the next lecture, we will set up a Python project. This is all from this video. Thank you for listening and have a great day. Hello and welcome. In this lecture, we are going to create our first API project in Python. Now, in order to create API project, we first need some tools and a virtual environment setup to start with. So, in this video, let me show you step by step how to set up development environment or virtual environment for Python project. These are the points which we will cover in this lecture. First, we will install Python. Then we will create a virtual environment. And finally, we will install FastAPI and UV in our virtual environment. Now let's look into these one by one. The first thing which we need to do is we need to install the latest version of Python. For this project, Python should be installed in your system. If you have not already installed Python, then head over to python.org And from there, you need to install the latest version of Python for your operating system. When you click on this button, an installer will start downloading. Double click on this installer and follow the installation steps to install Python on your machine. Once Python downloaded and installed in your system, to check the Python is successfully installed or not, open the command prompt or Windows and terminal in Mac in admin mode and type the command python hyphen hyphen version. When you press the enter, it will show you the version of Python installed in your machine. In my machine, Python 3.10.7 version is installed. This version might be different for you, but as long as you are seeing this version on your machine, you are good to go. If you see any error here, that means Python is not installed properly. In that case, you try reinstalling it. Let's create virtual environment. Once Python is successfully installed, now we need to create a project folder. Inside this folder, we will create a virtual environment for our API project. Virtual environment is a tool provided by Python by default. It is a tool that allows you to group Python packages to a specific folder. Normally, when you would install a package, it would install into a base Python installation of the operating system. In order to avoid cluttering of the base operating system, you can group all the Python dependencies for a particular project in a virtual environment. This is the way you can keep a separate set of dependencies of your project separated from other projects or an actual Python package which are installed in your operating system. If your operating system has Python friendly applications you have installed. So let's go ahead and create a Python virtual environment for our project. Make sure that we have opened the working project directory in Visual Studio Code and the terminal is also open in it. The way you can create virtual environment using Python is by typing python-m venv and the environment name. In my case, I am giving it name as virtual. Now hit enter button and go ahead to create virtual environment. You can see some new folders are created here with some basic dependencies for Python virtual environment. Remember one thing that we should not actually touch any of the file inside it. These files are here to run in the background of Python project. Whenever you install Python dependencies, they get installed into the virtual environment that is activated at the time you install it. Which means if you want to use virtual environment, we need to first activate it before we install and run any script of our project. The process to activate the virtual environment is different for Mac, Linux and Windows. To activate the virtual environment on Mac or Linux will be source virtual /bin/activate. And if you created virtual environment in Windows, we will have a different set of files and folder. And to activate the virtual environment in Windows, we need to type this command in terminal to activate the virtual environment. The command is source virtual/scripts/activate. Once you hit enter to activate virtual environment, you will notice the virtual prefix at the beginning of the terminal. This signifies that we have enabled virtual environment and currently working within the virtual environment. Now anything we install or any changes we make in our project will be applied to this virtual environment. The next thing I will show you how to deactivate the virtual environment. To do that, you simply type deactivate in the terminal and hit enter. You will notice that the prefix virtual disappears. That's how we can use virtual environment in our Python project. Now let's install FastAPI and UVCon. Before installation of FastAPI and UVCon, we need to ensure that the virtual environment of this project is activated. We will also have a basic understanding of FastAPI as well as UVCon. So let's see what FastAPI is. FastAPI is a modern, fast and high-performance web framework for building APIs and web applications with Python. It also has easy-to-use documentation. FastAPI also make it easy to build APIs and web application with Python. It supports ASGI web server. The next is UVCon. There are various servers like UVCon, GUnicorn and HyperCon that serves FastAPI. But we are using UVCon here because it supports asynchronous code and UVCon is ASGI web server implementation for Python. ASGI stands for Asynchronous Server Gateway Interface. Basically, it stands between outside world and the web application and handle the request from the clients. ASGI allows to run multiple events at the same time. This property makes it faster than other gateway interface like WSGI. At this stage, we are aware about FastAPI, UVCon, and activated the virtual environment. Now let us create a separate folder to keep our project related files and script inside. I have created a folder and name it as API project. Now change the directory and insert into the project folder and create main.py file as well as requirements.txt file. Write FastAPI in UVCode in requirements.txt file and install these dependencies in the virtual environment by using the command pip install -r requirements.txt. When it is finished downloading, you will see a success message. This brings us to the end of this video. In this lecture, we have installed Python, FastAPI, UVCon, and created virtual environment for our project. This is all from this video. Thank you for listening. Have a great day. Hello and welcome to the another video of API development series. So far in our project, we have learned about API, their type, and their working process. We have also installed required tools and modules for this project. In this video, we will see how to create REST endpoint using FastAPI. Whenever we are creating any kind of project, be it a software project, a data science project, or a machine learning or AI project, where you want to provide your services to the end users, you need to create an endpoint from which the user can access the product services. So in this video, we are going to see how to build an API with FastAPI. Here are the topics which we will be covering in this video. The first is we will create configuration.py file and main.py file. Next, we will also discuss about HTTP verbs. Let's start by creating configuration file inside core folder to store our project settings and name it config.py. Next, we will create main.py file inside our project folder and we will write these lines of code. Now let's understand what we did. We have imported FastAPI from FastAPI and settings from config.py file. Then we created an instance of FastAPI and initialized it with title and project version. Now we can reference the app as a FastAPI class object and can use it to create routes. Then we have created a decorator along with FastAPI instance and HTTP verb get. The decorator is used to provide extra functionality to a function. In the decorator, slash is the home endpoint for our API. Next is get. Get is an HTTP verb that determines the functionality allowed for a request. In this case, get means a user may connect to the home root to retrieve some information. Similarly, we have more verbs like get, post, put, and delete. Let's have a brief overview about each of these HTTP verbs. Request using get should only retrieve data. The post method is used to submit an entity to a specified resources, for example, submitting a form. The put method is used to update the database table record. Finally, the delete method deletes the specific resource from the database. Now, it's time to start the UVCon server. To do that, type UVCon main app hyphen reload in terminal. The hyphen reload flag is to tell UVCon to reload the application every time when we save any file of our project. Next, visit to the localhost at port number 8000 to see the JSON response at its endpoint. You will see the same message at the REST endpoint in JSON which we passed as a string in the app decorator. It brings us to the end of this lecture. So let's summarize the video first. In this video, we have created main.py file, configuration.py file. We have also learned about HTTP verbs and then we used UVCon to run the server and visited to the local host at port number 8000 to see the API response. This is all from this video. Thank you for listening. Have a nice day. In the last video, we created our very first FastAPI project. So we have our API project ready with dependent packages as we already imported necessary modules there. In this video, we will use API router and we will also see how to structure bigger applications. So let's first try to understand why we need API router when we can write entire code in main.py file itself. The answer is very simple. For a small application, it is okay to keep our code base in a single file. But as our code base grows or we are working on a bigger project, we will find it to be messy. So to keep our code base clean from the beginning, we are utilizing API router from FastAPI. Let's first see how our code will look like without API router. The code base shown in the main.py file is a non-routerish code. Here, for an example, it has home page, about page, contact page, and service page in a single file. Since this is an example, we have taken four basic functions for home, about, contact, and service endpoints. But in a real life scenario or in a big project, you may find more than 20 to 30 functions. Then routers will become necessary because handling too much complexity in a single page will make it a cumbersome job. So, router works with the purpose that while working in a team, you may have to divide complexity among the team members, which will help in completing the project much faster. Now, let's apply the same approach and divide the code into different files to divide the complexity. For that, I am creating one more file inside APIs folder and naming it as app_router.py. Let's understand what we did here. In this code, we imported API router from FastAPI. Then we created an instance of API router and named page_router. Next is home and about function, which will return a string at their respective endpoint. Now it's time to update our main.py file because the main.py file is unaware of this addition to our project. Thus, we need to inform main.py file to include page_router. We are done now, and you can also see that our main.py file is now clean compared than previous code in which all the endpoints were declared inside it. Now let's start the server by running the command uvcon main:\app-reload in the terminal and visit localhost at port number 8000. You should see the router response at both endpoints which we defined in the code. Here we are done with routers. Now you can use them to divide the complexity of your project without interrupting the functionality of API or code of main.py file. In addition, FastAPI provides interactive API documentation. It automatically generates the Swagger documentation for us. The API documentation allows us to test our API endpoint directly from the browser. We can get the API documentation by adding docs and redoc after FastAPI app URL and can play with the auto-generated Swagger documentation. For example, you can see the docs by visiting at the localhost and you will get this interface. Similarly, you can also visit to the redoc URL and can get this interface here. It brings us to the end of this session. Thank you for listening. Have a nice day. In the previous videos, we understood that FastAPI is a modern, fast, and a high-performance Python web framework. In this video, we will see how to connect FastAPI with the database with the help of SQL Alchemy. Here are the topics that we will be covering in this video. First, we will have a FastAPI brief overview again. Then, we will understand about object relational mapper. And we will also see what modular app structure is. Let's start by looking each of these one by one. As we are already aware that FastAPI is a fast, modern, and high-performance Python framework. FastAPI is based on Pydantic and starlette. FastAPI also integrates with many packages including ORMs. In this series, we are going to use SQL Alchemy ORM because FastAPI easily integrates with SQL Alchemy. And SQL Alchemy supports various databases like PostgreSQL, MySQL, Oracle, Microsoft SQL Server, and many more. Next, see what is ORM. ORM stands for Object Relational Mapper. And SQL Alchemy ORM is a mapper which helps to translate the database table record to a class object. Basically, SQL Alchemy is a library that facilitates the communication between Python program and different databases. Next, let us see what modular app structure is. When we are writing an application, it is a best practice to create independent and modular Python codes because small and subprograms are easy to write, design, and understand compared them to the larger ones. Thus, modularization makes development quicker and it also helps to make our project maintainable. The another benefit of writing a software into the subprograms or in modules that modules are reusable because it is easy to relocate or link them with other application or code where they can fulfill similar tasks. Apart from this, modularized applications are easier to manage and scale. Now, let us open the Visual Studio Code and see what we are going to build today. We are going to create a separate folder to keep the database related files. In this folder, we will be creating a session.py file, a base file, and a base underscore class py file. And we will also update main.py file with base.metadata.create underscore all and bind it with the engine to create tables and modules for our database. The SQL alchemies is underscore declarative and base.metadata.create underscore all allows us to write a class to use many times in our program to use in DB. To begin with, first open the requirements.txt file and write SQL Alchemy and PSYCOPG2 libraries for database connection. Then install these dependencies using the command pip install -r requirements.txt in terminal. Now let's create a database connection. For this, I'm going to create a separate folder named db. Inside db folder, I will create session.py, base.py and base underscore.py file. Let us first create session.py file. In this file, we are creating SQL Alchemy engine with SQLite database URL. Then we are creating session local. The session local class instance will be the actual database session. Next, create another file and name it base underscore class.py inside the db folder. In this file, we will create models for database. A model class is a Pythonic representation of a database table. Now, we will create a super duper class. Every model will inherit this base class and we will utilize this base class to create all the database tables. Next, let me create another file and name it base.py file. The base.py file will have all the modules related to the tables created in database folder. Now we need to update main.py file. So head over to main.py file because whatever changes we have made in our API project, we need to tell main.py file about those changes we made in our project. So we need to update this file. Here we have imported the engine from db.sessions and base class from base.py and then we bind the engine with base.metadata.createAll bind equals to engine. With this, we are done with our code. Now it's time to run the Unicon server. So type unicon main app hyphen reload in terminal. As soon as you hit enter, you will see an SQLite database is created in the same project directory. That's all from this video. Thank you for listening. Have a nice day. Hello and welcome. So far, we have seen various things. We have already done with database connection, created the session, and we also created the base class for all the tables and updated our main.py file. Now in this video, we will see how to create models for our table, followed by verification of tables in SQLite database. Then we will see how to create Pydantic schemas. Finally, we will understand the dependencies and will create dependency injection in FastAPI. Let's first understand what a model is. A model is a Pythonic representation of a database table. And today, we will create a model to hold the class equivalent of DB tables. We can create models as per our project need. Like if we are working on an e-commerce site, then we should create models for product, admin, users, and etc. Similarly, if we want to develop a job portal, then we should create a model to keep records of jobs, users, and other fields. In this project, we will create a model which is going to store the details of books. The details we are going to save for the book model will have book title, author of book, book description, and the rating. So now create a new folder named models inside the DB directory. Then in the models folder, I am going to create a new file, say books.py. In this file, first we are taking column, integer and strings from SQL Alchemy. Then I inherit the base class from the base underscore class.py file. We are inheriting it to have a class-based representation of tables because each property or attribute of this class will be translated into a column of the table. Next, we have the ID column. It can store integer value and it is a primary key with index equal to true. The title column represents the title of the book and it can store a string. Next, we have author and description column. These columns can also store strings. Last, there is a rating column which can store an integer value. With this, our model is created. Now this time we do not need to make any changes in main.py file because we already added base class in main file from base.py file of DB folder. Next we need to run the server and let's check the created tables in the database. To check the tables, let's go to the SQLiteonline.com. This is an SQL Online IDE and the best part of it that you do not need to install it. You can use it through the browser of any operating system like Windows, Mac and Linux. Next, click on the file and open DB. Then locate the database path which is inside the project directory. Select the file and click OK. We can see the books table inside our database. You will have the name of the columns which we declared while creating the models. The next topic is schemas. We have done a lot of things. Now it's time to go deep and see what are the required things to perform CRUD operation using FastAPI. So let's start by writing schemas for Pydantic. Remember in previous videos we discussed that FastAPI is built upon Pydantic. Here we will define objects in Pydantic via models that inherits from base model. Pydantic guarantees that the data field of the resultant model confirms the field type we have defined using standard modern Python type for the model. We will also use ORM underscore mode is equals to true because it will allow our app to take ORM objects and translate them into responses automatically. This automation saves us from manually taking data out of ORM, making it into the dictionary and then loading it with Pydantic. In simple words, our created Pydantic classes will verify user inserted data type. These classes are called as schemas. Let's again go back to the Visual Studio Code and see it in action. Before that, we will create files and folders to hold schemas. Here, I am creating a new folder in the project directory called schemas and a file books.py inside it. Then we will import base model and field from Pydantic. Next, we will create Pydantic classes to create books. I am giving it the name is book create with B capital and C capital. You can name it whatever you want. Now, in this class, we are inheriting the base model from Pydantic, which helps FastAPI to suggest validation error to user. Here, whenever we want to create a book, we will receive data in a JSON format where the book title will be verified as a string with a minimum field length equals to 1. Then the author will be validated to be a string with minimum field length. Similarly, the description will also be validated to be a string with minimum and maximum field length. And finally, The rating part will be validated to be an integer value. With this, we are done with the schema part. Next, we will understand the dependencies in FastAPI. Well, dependency injection is a beautiful concept. It is a design pattern in which an object or a function receives another object or function that it depends on. Or we can say the dependency injection allows decoupling database setting during the production and the test environment. That means during production, we would need a different database, and during the test, different database will be used. This can be achieved by dependency injection. This dependency will guide our database connection. Now, let me import the generator from typing to create a dependency get underscore db. It will help to convert the session into Pydantic things. Inside the dependency get underscore db, I am creating db as a session local. Then we can try yield db. And finally, I am closing the db. This means everything is closed in the database connection. It brings us to the end of this lecture. Thank you for listening. Have a nice day. Hello and welcome to the API development series with FastAPI. In the previous lecture, we learned about models, schemas, and dependency injection. Now, in this video, we will start by creating an API route to create new books with the help of HTTP verbs and API router. We already covered API router in this series. In case of any confusion, you can see setup API router in FastAPI video once again. Next, we will create a new folder for API versioning inside APIs folder. After that, we will also create a repository folder inside the DB directory. Then in the repository folder, we will again create a new file named books.py to keep ORM queries and functions related to the books table. Now it's time to create an API route. I am sure you remember we created a simple route in the previous lecture. If not, you can see the video how to create REST endpoint using FastAPI. So let's go ahead and see what else we are going to do. This time we will create an API route by using Pydantic schemas, database connection, and dependency injection. Then we will also perform CRUD operation on those API routes or paths and will get books details from the database. For that, we will create a new folder structure to make an API route for books, which we already discussed at the beginning of this video. So let me create a base.py file inside the APIs folder. Here we have API router from FastAPI. Then we have route underscore books from version folder of APIs directory. Next, we have an API router instance, and finally we include the router of route underscore dot books dot py file with it and declare the prefix and tags as /books and books respectively. Next, I am creating a new folder named version1 and a route underscore books.py file. Since we just created this folder, so I named it version1. Later you can change this folder's name to version2, version3 and so on as per your add-ons on the project. Now in the route underscore books.py file, we have API router and depends from FastAPI, session from SQL Alchemy ORM, book create schema from schema.books, dependency injection from db session, and create underscore new underscore book function from books file of repository folder. Then again, we have created an instance of API router and using this API router instance with post request. Next, we have schema book create in the post request, which was imported from the schemas. And we also have a db argument in the book underscore create function, where db is going to be a SQL Alchemy session. Then we have made the session value which depends on the dependency injection, that is get underscore db. Next, we are using create underscore new underscore book function from the books.py file of the repository folder and passing the book and db in it. And finally, we are returning the book. So now let me create a repository folder in the db directory, and for the ORM queries, a books.py file is also created in the same folder. These queries will communicate with the database. Here, let me import this session from SQL Alchemy ORM. Again, book create schema from schemas and book model from db.models. Next, we will make some functions and will use these functions to create, read, update, and delete the data from the database. So first I am creating create underscore new underscore book function with schema book create with B capital and C capital and the database session. Next, I created a book object for a new book with the help of book model. In this book object, we have the title, author, description, and rating field. Then we need to tell the database to add this new book. When the book is successfully added to the database, we will commit it with db.commit command. Then we will refresh the db with the new book object and finally returning the book object. Now let me run the server and test this path on the Swagger documentation. Here I am giving the book title, author, description and rating. And when I execute the execute button, I can see the response in the response body. In the response body, we are not only getting the title, author, description and rating, but we are also getting the ID from the database, which we declared in the models as the primary key is equals to true. Now, if we check the database on the SQLite Online IDE and run the select query, select star from books, we will see this book entry here. With this, we created a post route or path using the API router. Let me recap what we did. First, we had the necessary imports in the route underscore.py file. Then we had book schema and defined db as SQL Alchemy ORM session, where this session's default value should depends on the db, that is get underscore db. After that, we are passing the both schema and db session to create book and create new book function of books.py file of repository folder. Next, inside the books.py file of the repository folder, we have a book object which is a book model. With this model, we created a table structure. Next, let's move forward and see how to get books from the database. Now it's time to define a function in route underscore books.py that will return all the books from the database. Let's see how we can do that. We need a database session to get all the books. Then we used list underscore books, which was taken from the repository, and finally returning the book. Next, go to the repository folder. Here we are using the same database session and queried the books from the DB with the command db.query book.all. This command is similar to select star from books. Reload the Swagger documentation and now we will see the get path appears here. When we try this get path and execute the get request, we can see the list of all the books from the database. You can also check all the books on the URL localhost :8000 /books /all. It will show you the books from the database here as well. Next, we will see how to get books by their ID. For that, I am again going back to the route books file and importing the retrieve book function from the repository folder. Along with, I am also importing HTTP exception and status from FastAPI. Next, we need to create one more path with the get method and will pass the ID parameter in it. Then we created a read function with ID and database session and passing the same ID and DB session to retrieve books. Next, I am raising an HTTP exception to check if the book with the given ID is available in the database or not, and returned the response in the f string which says book with ID does not exist. Finally, we are returning the book. Now go to the books.py file of repository folder and write a query to the database model books. In this function, we are using the same ID and DB session coming from the route books and then filtering with the ID. Here we need the first value with the requested parameter, so adding the SQL alchemies dot first also. The dot first will give us the first value which meets the condition. This query is similar to select star from books where book ID is equal to requested ID. Next, go to the documentation again and reload the page. You will see we have one more route with the get method. Let me check the book by ID number 3. As soon as I click on execute button, we will see the result in the response body. But if I want to see the book which is not in the database, then it will give an error. For example, if I pass ID 6, obviously it will give an error that says book with ID 6 does not exist with 404 error. You can also get the book with ID by visiting the local host at port number 8000 /books or /book ID. Book ID like 3. You can also check with the book ID 4, and if you try to access the URL for the book ID which is not available in the database, then you will see this error on the browser. So that's all from this video. Thank you for listening. Have a nice day.